Good morning, everyone. I think we're going to get started for the sake of time. This webinar is a little bit of a shorter one, so we're going to just kick it off. I just wanted to welcome everyone to our webinar today, highlighting BEYOLEX, which is Panasonic's new high-temperature stretchable film for soft circuit applications. I'm going to be joined by Andy Baer today, who's the Business Director of Panasonic Electronics Materials in North America. Long title, but great to have you there, Andy. So we're going to be sharing a little bit of the presentation today, and then we're going to jump into a demo. So why don't I kick off by just highlighting what the agenda is going to look like, and then we'll get right into our presentations. So the agenda for today, I'm going to kick things off by just giving a quick introduction to Nova, which is Voltera's new modular dispensing system. And then that should take about 5 minutes. Then I'm going to hand things off to Andy, and he's going to provide a great overview of BEYOLEX and some of the great applications that it can be used for, and just why it's such a cool and novel substrate to work with. And once Andy's done with that, he's going to hand it back over to me, and we're going to do a print demo with BEYOLEX, and I'm going to be using ACI's silver stretchable ink 1109 to print a force sensitive resistor live for you guys. And we should have some time at the end for any Q&A. Though I do want to mention we've got a ton of people ready in the chat to answer your questions. So we've got a few folks from Voltera. We've got Marshall from ACI, who's happy to answer questions about their inks. When Andy's not presenting, he's going to be happy to answer questions in the chat as well. So feel free to post them throughout the presentation, and we'll get to them there. And I do want to just do a quick plug as well. If you stick around to the end of the webinar, we'll be sharing an exclusive promo code that you can use towards the purchase of a Nova. So I think that covers all the groundwork for today. So I'll just jump into Nova and we'll get things started. So just want to introduce you guys to Nova. So Nova, what is it? Nova is a benchtop modular dispensing system that can help you streamline your research and development with direct ink writing and dispensing. So what does that mean? It means no tooling. You don't need to build custom things for every one of your projects. There's less waste, less cleanup. It really streamlines what you're capable of doing from your desktop. It also helps you accelerate your workflows with intelligent calibration and alignment. Well, we've got a lot of neat software and machine learning stuff built into Nova's system to help you with your projects. And Nova can be configurable for your needs with a bunch of quick swap modules and the customizable work area. So it's capable of doing a lot more than just one task. So why don't we take a quick peek at the anatomy for Nova here. So it's been designed from the ground up with modularity in mind, meaning that Nova is going to grow with you. Currently, we ship Nova with a smart dispenser, a smart touch probe, as well as a vacuum module. We're looking at expanding this modularity into the future, and we've designed it that way from the get-go. So looking at some of the tools, like I mentioned, the smart probe. It comes with a high accuracy ruby tip stylus, and inside the inner workings of what's making it sense are carbon resistors, which allow up to a 2.5 micron accuracy when you're creating your height maps. And then in the software, when you're working with the probe, you have the customization ability to increase or decrease the amount of probing points on your substrate to get more and more accuracy as you're working. When it comes to the smart dispenser, we use a positive displacement system to eject the ink. And we have a pressure sensing nozzle or a pressure sensor right near the nozzle tip, which just allows for incredibly high resolution features down to about 100 micron trace width, depending on the materials you're working with. We also have a built-in heater to control the viscosity of inks. And so what that allows you to do is get consistent prints from day to day, working with the machines using different materials, but also the same materials. And it also unlocks our ability to use a wide range of compatible viscosities from all the way down from 1,000 1,000 to 1,000,000 centipoise. So just a huge range that dispenser unlocks with the pressure sensor and the built-in heater. I mentioned previously about the vacuum module as well. But yeah, we've again designed the work area for Nova to be modular as well. So if you're using soft or conformable substrates, the vacuum module is going to be great for that. It has a porous titanium, which just allows for incredible uniform hold down when using the vacuum attachment. But we also have a custom fixturing grid that uses standard M5 mounting screws to give you the ability for application-specific fixturing. So you could 3D print or come up with your own tooling to hold down your projects if you have something that you need specifically done. Nova comes with a built-in onboard camera as well. So this allows you to easily scan your prints for quality control afterwards. It also allows you to use our AR overlay to see your prints and align things before you actually do your print. So you make sure that everything's lined up and is printing exactly where you want. And yeah, like it said, it allows you to inspect a line within a 17 micron to pixel resolution. And you can also capture images to save for measuring those pass spacings and trace widths down to that pixel level as well. We also have a dedicated material support team or material science team in-house that have built a large network of materials and manufacturers. That's why we're hanging out with a couple of our great friends today at Panasonic and ACI. Yeah, it's just a great example of a few of the relationships we've built. But yeah, with Nova comes our materials team. And if you're looking for a specific material or application to try and get to, we can absolutely point you in the right direction with that stuff, and we'd be willing to help out. I just want to kind of highlight a couple example prints using Nova here. So we've got some copper ink prints, we've got some silver and carbon prints on a variety of different substrates here. But yeah, we've done a ton more, so do check out our website and our blogs for our most updated projects that we've been working on. And then just kind of wrapping things up on Nova, we've baked in a ton of quality of life improvements everywhere from just the intuitive UX interface that we've built. All the software for Nova is browser-based. You can connect to the machine over Wi-Fi. But yeah, some of the great other improvements here that I just want to touch on a couple of them. The central materials library. So when you're loading in your files and loading in your materials that you want to work with on a regular basis, you can access those all at any point and share them between team members there as well. But yeah, I don't want to go touch on each of these. Definitely reach out to us if you're looking for some of these more quality of life improvements. But the big key takeaways for Nova is it allows you to unlock new opportunities and really push the limits of functional material research and development. It allows you to streamline that. You can get instant feedback on the projects that you're working on and really total material freedom. You can experiment with a huge range of materials when working with Nova. So if you're interested in more information and just want to hear more, feel free to reach out to our sales team, sales@voltera.io, or if you just go to our website, voltera.io, and hit the chat icon in the bottom corner, you can reach out to them there. And I do want to just give the plug again. If you stick around to the end of the webinar, we'll be sharing that exclusive promo code for Nova as well. So that wraps things up on my end for just the quick overview of Nova. So I'm going to hand things over to Andy Bear to talk a bit more about BEYOLEX today.
Well, good morning, Nathan. Can you hear me just fine?
I can hear you perfectly, Andy.
Oh,
great.
Wonderful. Well, I'm going to share my screen here and I'll just share it. So basically, thanks for being adaptable. I want to talk a little bit about our soft circuit materials development based on our novel thermoset conformable and stretchable chemistry. We brand named it BEYOLEX. This is unlike anything that's out in the world. It's a non-silicone, high temperature, high performance material. Quickly, here's a evolutionary roadmap of where we started in circuits, and I'm not denigrating rigid or flex circuits. They're a very good business for Panasonic, and we do lead the market in high speed, high performance circuit materials. And as new applications have developed in wearables and robotics and other applications down the road, medical health, sensing, there's been new requirements for circuit materials that didn't exist before, things like conformability, aesthetics, stretchability. And so we're just starting into the world of soft circuit materials, and we feel we have a good leadership position in our technology. Here's just some pictures of some examples that are out and about in the market. Our BEYOLEX product portfolio, pretty limited right now. We have our substrate film, the BEYOLEX film, and that's what Nathan is going to be printing on here in a little bit. And again, high elongation, high temperature resistance, really good base substrate for printed electronics, or FHE, which are flexible hybrid electronics. In the same vein, we're beta testing our overlay or top coat or adhesive film. Basically, it's a B stage or partially cured version that can be used to go over the top of the circuits as a protective layer or bond as an adhesive. And down below, you see the delivery structure on both those materials. Here's a quick overview of the property table of the BEYOLEX, and I would like to highlight a couple of items here. Number one, the elongation is above 200%. This does stretch to above 200%. Second, the hysteresis is practically zero. And for those that don't know, hysteresis is the permanent deformation after strain. And for those of you that have used saran wrap, when you stretch it, it never quite goes back to its original shape. The same thing happens with other thermoplastic films like TPU, which is thermoplastic polyurethane. But the high cross-linking density in the BEYOLEX film allows it to return to its original shape. And then I really want to highlight the thermal decomposition temp is above 300 C, meaning that it can survive a lot of assembly processes, and it's also indicative of some of the environmental performance that it has. Here's a quick comparison of where the BEYOLEX film is positioned relative to thermoplastic materials. You see a TPU there, and silicone materials are fairly popular and in use, but they do have some printability challenges we've found. So this is where the BEYOLEX sits in comparison to those other materials. I'd just like to highlight a quick difference here. Here's a temperature and humidity exposure test we did comparing BEYOLEX to a typical TPU, 8585. This was a 1,000-hour test, and then we measured the elongation among other properties. And you can see that the TPU started off very, very well with high elongation, but almost instantly it degraded to the point where it couldn't even be measured because it just degraded. Whereas the BEYOLEX maintained its mechanical properties and physical properties through the 1,000 hours. And again, this is just an indicator of the difference between a thermoset and a thermoplastic material. One of the best videos we have is out of our lab, which shows a solder float test, a 260C SAC 305 solder float test. I didn't want to risk trying to play a video during the webinar. There will be a link to the video on the website in the webinar follow-up. But what you can see is basically instantly PET, even high temp PET, wrinkles up. The TPU just turns soft and mechanically degrades. And the BEYOLEX can sit in there for more than a minute or even longer directly in the solder float. And again, this was a lab test, so it picked up some dross in there, but it mechanically didn't change the properties at all. Really briefly, so what kind of use cases or what can be done with a BEYOLEX or a high temp conformable and stretchable film? There's a robotic motion sensor over there that's a resistive sensor. In the middle is a flexible heater. On the right, this is a NFC part that was laminated, over-laminated with the top coat, means it was completely waterproof and immersible and wire-free. So that was a lot of fun to work on. Lighting is another area that's got a lot of interest. Again, could be used for digital signage or other applications. One of our earliest applications was a sensor patch, which had a location sensor and a motion sensor in it. And then on the right is just a quick little close up of a component that was on a hybrid system. You can see the silver and the copper, but those components were reflow soldered with SAC 305 solder to create a functional circuit. So again, just a little bit of a teaser, just a quick overview of the technology, and feel free to reach out. Happy to answer any questions. Looking forward to the printing demo, and thanks again for everybody's time and interest.
Awesome. Thanks so much, Andy. Yeah, great to see just the deep dive in there. And yeah, of course, you can reach out to their team. I'm going to have some email information at the end of the presentation on how you can reach out to them. I think there's already some questions pouring in for you as well, Andy, in the chat. So yeah, feel free to jump in there and start answering. In the meantime, yeah, I'm going to get started with our print demo today. I'm not going to highlight, or I'm not going to dig deep into any of the specific features. I really just want to get the printer printing for you so you can see it happen. And then I'm going to jump over to a pre-cured sample that I can show off for you guys at the end here as well. So I'm going to start a new dispense cycle here. And I'm going to select the materials we're working with today from my library on the left. So I've got my ACI SS1109 silver stretchable ink, and we've got BEYOLEX. Perfect. And then I'm just going to choose a file for us to print today. And it's just going to take a moment for the software to load in the file and process all the tool paths for our flexible sensors today. And you can see, yeah, we've got all those loaded in and it's looking great. I've already pre-mounted my substrate, as you can see here, just on the bed. It's loaded up there on the vacuum module. So I'm ready to move to the next step. So for alignment here, I'm just going to do a really quick and basic alignment. There's nothing specific I need to look out for. I've got a completely blank sheet here. So I'm just really moving it to the spot in the software that I would like it to be in. So first things first, the camera is just going to find its center on the XYZ positioner tool. And once it has that, we're able to move over top of our substrate to find where we would like to print. And I can switch between the camera view and the background view as well to dial in where I would like the pattern to show up and be printed later on. Perfect. So just going to move it down to this lower section here. Perfect. I think I'm pretty happy with that. But this is, yeah, just an example of the AR overlay highlighting where we're going to be printing. Perfect. So now I've got the print file exactly where I want to be printing it, just at the bottom edge of this bed. And now I'm just going to move into the probing step so that we can get ourselves a height map for dispensing. And as you can see, the probe is interacting with the XYZ positioner tool here. And so it's just getting the center of the tool in X and Y, as well as the Z height, so that it knows exactly where that tip of the probe is in three-dimensional space. And from there, we can get a really nice, accurate probing map. And you see it's going over to probe the calibration area first. This is because we're going to be doing a quick flow check before we do our print. We don't need to fully calibrate our material. We already have those settings locked in from a previous calibration. But we do want to make sure that ink is flowing out the tip of our nozzle before we do go end up to print. So yeah, we do need to probe the calibration plate just before we probe our substrate as well. And then we move over to our substrate to probe where we're going to be printing. And you can see in the software as well, as we probe, the probing points get marked off that they are completed by filling solid blue here. And like I mentioned previously, the amount of probing points can be changed. This is one of the settings that you can set with your material. It's the probe pitch setting. So if you need a even more accurate height map, you can increase the number of probe points that are showing up here. And if your substrate is fairly uniform and speeds all you care about, you can reduce the number of probing points as well and save yourself a little bit of time. We're kind of right in the middle balance here of speed and accuracy. We've definitely got enough points for our print today that we're able to interpolate the data in between and get a really nice accurate height map. And it's not going to take us ages to do it. So we're just about there. Just a couple probe points left. Perfect. So the machine's just moving to its home position, and we're able to move on because we've got a nice height map that we're happy with. So I already have our dispenser set up here for our print today. So I don't need to worry about this step, but we're going to move right into the flow check. So again, we're going to position the tool on the dispenser on the XYZ positioner tool as well, so we can know exactly where that tip of the nozzle is in 3D space, and that we can print at our set print height above the height map we just measured. Perfect. And with that locked in, it's going to move over to our calibration plate and print the flow check. And so it's just going to print a series of lines. And all we're looking here is to make sure that we see ink running out of the nozzle. I've already done a test print this morning, so the ink should be flowing for me. But for those who might be printing for the first time in the day, yeah, there's no issue with it taking a couple passes for ink to get flowing. But everything's looking good here. I can see that I've got some lines going, so I can move right to printing. Now, if I want to print all three of these sensors today, they're all pre-selected for me to do so. But if I wanted to just print one of them or just print two of them, I can easily just select just to print one. I could just print two. But yeah, I think for time today, I'll just print the middle one. So I'll select that one and we'll hit start. And so it's going to immediately go and start printing our design here. And I do want to highlight that if we notice that we've got maybe a little bit too much ink flowing out from the calibrated settings we had previously, we can adjust those on the fly here as well. But I'm going to switch over just to let you watch Nova print here. So while it's printing, we touched on why BEYOLEX is a great choice for a stretchable substrate. But yeah, just wanted to touch on why we went with the ACI SS 1109 as our conductive ink to print with for this. And the main reason is because it matches up with BEYOLEX's 200% stretchability. So the ink is able to withstand that deformation and can return back to its shape as well. And it's got excellent conductivity and has a rapid return after strain. So it really pairs up well with the BEYOLEX material. And the other piece is it is well below BEYOLEX's curing temperatures. The silver ink only needs about 135 C for 5 minutes in a box oven. So that is well within the 300 degrees C that BEYOLEX can handle. So yeah, really great option for this pairing for today. Perfect. And so our print is already done there. So we can click next and we can go and inspect our print if we like. And this is where I can finally turn the lights on. But yeah, we can see that our ink deposited really nicely here. I'd be able to change the step size of how we move our camera here on the traces. But yeah, instead of showing you this really close-up print, I did a little bit of TV magic, and I have a print already ready for you to go that I can show that's been cured here as well. So I'm just going to home the machine, switch over to the big camera, and yeah, just going to highlight the cured version of our print here on BEYOLEX. So you can see we've got our FSR sensor here, and just yeah, incredible ability to stretch to that 200% mark, and then it almost immediately just returns back to its shape. It's incredible. And it's got a really unique feel in hand as well. So yeah, it's definitely worth checking out if you require a conformable or a stretchable substrate. Yeah, just really cool. So I'll do a couple more stretches here just so you can see it on camera. Yeah, just really cool. Awesome. So for the demo side of things, I think that concludes where we're at. So yeah, I'll just open up the floor for any chat questions. I think we're pretty much at time. So I guess any questions that didn't get answered in chat, feel free to reach out to Rick Trunnell at usapanasonic.com about BEYOLEX, and any questions about ACI inks can go to Kay Fenwick at acimaterials.com. And then I'll just be highlighting the promo code here, BEYOLEX. So if you reach out to our sales team, just mention the promo code BEYOLEX to save off your Nova purchase as well. Perfect. So I want to thank Andy again for being here, and everybody who is available in the chat to answer questions, Marshall from ACI and the folks at Voltera. Yeah, and appreciate everybody who attended the webinar today. Thank you very much, and have a great rest of your day.